Hello, in this lecture we will find the value of x using two different methods. In the drawing we have right triangle ABC, angle ABC equals to 90 degrees. We also know that angle BAD equals to alpha, angle DAE also equal to alpha, and angle EAC, this angle also equals to alpha. We also know that line segment BD equals to 3 units, DE equals to 4 units, and we want to find out the value of EC that equals to x. Okay, so first of all I will present to you the angle bisector theorem. So what is angle bisector theorem? Angle bisector theorem. Actually, AD bisects angle BAC. That is to say, AD divides angle BAC to two equal parts. If this angle is theta, this angle will go also equal to theta. Okay? Again, the angle bisector AD divides angle BAC to two equal parts, theta and theta. And according to angle bisector theorem, an angle bisector in a triangle divides the side it hits in a ratio that equals to the ratio of the angle legs. I will read the angle bisector theorem again. An angle bisector in a triangle divides the side it hits in a ratio that equals to the ratio of the angle legs. So actually, according to angle bisector theorem, the angle bisector, first of all, AD is angle bisector because of the fact that it bisects angle BAC. It bisects this angle, that is to say, it divides angle BAC to two equal parts, theta and theta. Okay, so according to angle bisector theorem, an angle bisector in a triangle divides the side it hits. The angle bisector AD hits side BC of the triangle, and it divides it in a ratio that equals to the ratio of the angle legs. So the angle bisector AD hits side BC at point D and divides it in a ratio of BD over DC. Okay, BD over DC is the ratio that angle bisector AD divides side BC. BD over DC. Okay, and that ratio equals to the ratio of angle legs. The angle legs is angle BAC, and the legs of angle BAC are AB and AC, and the ratio between those legs is AB over AC. Again, the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to the ratio between the angle legs, that is to say AB over AC. Okay? The ratio that angle bisector AD divides side BC is BD over DC, and that ratio equals to the ratio between the angle legs, between AB and AC, and the ratio between AB and AC is AB over AC. Okay, so that is the angle bisector theorem that we will use in both methods, in method number 1 and also in method 2, in the second method. So in this drawing we will focus on the right triangle BAE. Okay, on the right triangle BAE or ABE, it is the same. The right triangle ABE, we know that AD is angle bisector. AD is angle bisector. I will repeat again. In the right triangle ABE, AD is angle bisector. So why AD is angle bisector in the right triangle ABE because of the fact that AD bisects angle BAE. That is to say, AD divides angle BAE to two equal parts, alpha and alpha. Therefore, AD is angle bisector of the right triangle ABE. Therefore, according to angle bisector theorem, the angle bisector AD divides side BE in a ratio that equals to the ratio of angle legs. The ratio that angle bisector AD divides BE is actually BD over DE. Okay, BD over DE is the ratio that angle bisector divides side BE of triangle ABE. Okay, that is the ratio that angle bisector AD divides side BE of triangle ABE. And that ratio equals to the ratio between the angle legs. May relate to angle ABE, and the legs of angle ABE are AB and AE. So the ratio between the legs of angle ABE is AB over AE. Okay? Again, the ratio that angle bisector BE divide the ratio that angle bisector AD divides side BE of triangle ABE is BD over DE, and that ratio equals to the ratio between the angle legs, that is to say, to AB over AE. Okay? So what is the size of BD? BD equals to 3 units. What is the size BD equals to 3 units, and what is the size of DE? DE equals to 4 units. So in total we got the equality that AB over AE equals to 3 over 4. AB over AE equals to 3 over 4. We will define AB as 3K. That is to say, AB will be equal to 3K according to our definition. And we will find out the value of AE in this equality when AB equals to 3K. So we will place the value of 3K and in variable AB, because AB equals to 3K, and we will get that (3K over AE) equals to 3 over 4. So we actually placed the value of 3K in variable AB, because AB equals to 3K, and we got this equality. We will multiply this equality by AE, and we will get that (3K) equals to 3 over 4 times AE. Here we will multiply this equality by 4. We will get that 12K equals to 3 times AE. Here we will divide this equality by 3. Twelve over 3 is 4, so 4K equals to AE. So we found out that if AB equals to 3K, then AE must be equal to 4K. Okay? So we will continue to focus on the right triangle, triangle ABE. We know that in the right triangle, triangle ABE, according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle, triangle ABE. That is to say, AB square plus DE square plus BE square equals to AE square. Again, according to the Pythagorean theorem, in the right triangle, triangle ABE, AB square plus BE square equals to AE square. What is the value of AB? We have already found out that the value of AB is 3K. So AB square will be equal to 3K square. What is the value of BE? BE equals to 3 plus 4, that is to say to 7, so BE square will be equal to 7 square. And what is the value of AE? All equals to AE square. And what is the value of AE? AE equals to 4K. So in total we will get that 3K square plus 7 square is 49 equals to AE square. AE equals to 4K, so AE square is 4K square. So here we will open the brackets in this equality and we will get that 3K square is actually 9K square plus 49 equals to 4K square. 4K square is 16K square. Here we will subtract 9K square from this equality and we will get that 49 equals to 16 minus 9 is 7 equals to 7K square. Here we will divide this equality by 7 and we will get that K square equals to 7. we will take a root out of this equality, and we will get that k equals to the root of 7 units. So we actually found out that k equals to the positive root of 7 because of the fact that k is the size of the side of the triangle. It must be a positive number, so it is actually the positive root of 7. Okay, and we know that AB equals to 3k according to our definition, and we have already found out that AE equals to 4k. So we will place the value of k in the variable AB, and we will get that AB equals to 3 times root 7. And we will also place the value of k in variable AB, in variable AE, and we will get that AE equals to 4 times root 7. So we found out the values of AB and AE, and in the next step we will focus on the right triangle, triangle ABC, the right big triangle, triangle ABC. On the right big triangle, triangle ABC, we know that tangents 3 alpha equals to BC over AB. Okay, in the right big triangle, triangle ABC, we know that tangents 3 alpha equals to BC over AB. Okay, but what is the value of BC? From the drawing you can see that the value of BC is 3 plus 4 plus x. 3 plus 4 is 7, so the total, the size of BC is actually 7 plus x. Okay, so BC equals to 7 plus x, and we have already found out that the value of AB is 3 times root 7. So in total we found out that the value of tangents 3 alpha equals to 7 plus x over 3 times root 7. So I'll write it down. The value of tangents 3 alpha is 7 plus x over 3 times root 7. So in the next step we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. In the right triangle, triangle ABE, we know that tangents 2 alpha equals to BE over AB. But what is the value of BE? From the drawing, we can see that the value of BE is 3 plus 4. That is to say 7. And what is the value of AB? According to our definition, actually we have already found out that the value of AB is 3 times root 7. Okay, so in total we got that the value of tangents 2 alpha equals to 7 over 3 times root 7. So I write it down. The value of tangents 2 alpha equals to 7 over 3 times root 7. In the next step we will focus on the right triangle, triangle ABD. In the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. Okay, on the right triangle, triangle ABD, we know that tangents alpha equals to BD over AB. But what is the value of BD? BD equals to 3 units. And we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangents alpha equals to 3 over 3 times root 7. So I will write it down. The value of tangents alpha equals to 3 over 3 times root 7. So we actually found out the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha. Okay? But we also know that tangents 3 alpha equals to tangents 2 alpha plus alpha. Okay, and in order to find out the value of tangents 2 alpha plus alpha, I will present to you a new trigonometric identity that is actually tangents A plus B it equals to tangents A plus tangents B over 1 minus tangents A times tangents B. Again, the value of tangents A plus B is tangents A plus tangents B over 1 minus tangents A times tangents B. So we will use this trigonometric identity in order to find out the value of tangents 2 alpha plus alpha. So we will get that the value of tangents 2 alpha plus alpha, that is actually tangents 3 alpha, according to this trigonometric identity, will be tangents 2 alpha plus tangents alpha over 1 minus tangents 2 alpha times tangent alpha. Okay, so we actually found out the value of tangents to alpha plus alpha according to this trigonometric identity, but we have already found out the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha. So we actually can place the values of tangents alpha, tangents 2 alpha, and tangents 3 alpha that we found here in this equality. Okay, and we will get that tangents 3 alpha is actually 7 plus x over 3 times root 7. It equals to tangents to alpha. The value of tangents to alpha that we have already found out is 7 over 3 times root 7 plus tangents alpha is 3 over 3 times root 7, all divided by 1 minus tangents 2 alpha times tangents alpha. So actually this is the equality that we arrived after we place the values of tangents 2 alpha, tangents 3 alpha, and tangents 3 alpha, tangents 2 alpha, tangents alpha, tangents 2 alpha, and tangents 3 alpha in this equality. So this is the equality that we arrived to. So here we will substitute the value of 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7 in order to have a common factor with this expression. And we will get that 7 plus x over 3 times root 7 equals, here we have 3 plus 7 plus 3 is 10. In the denominator we have 3 times root 7 all divided. As I already said, we will substitute the value of 1 by 3 times root 7 times 3 times root 7 over 3 times root 7 times 3 times root 7. So we substituted the value of 1, we substituted 1 by this expression. As you can see, this expression equals to 1. Okay? And here we have minus 7 times 3 is 21. Okay, in total we got this equality. Here we will move this expression to the numerator here, and we'll move this expression to the denominator here. And we will get that seven plus x over 3 times root 7 equals to 10. This expression will be moved to the numerator here. 3 times root 7 times 3 times root 7 over 3 times root 7, and this expression will be moved to the denominator here. So it is 3 times root 7 times 3 times root 7 minus 21. Okay, so here we have 3 times root 7 in the numerator, and we have 3 times root 7 in the denominator. So 3 times root 7 will get cancelled, and what is left after we cancel 3 times root 7 in this equality is 7 plus x over 3 times root 7 equals, here we have 10 times 3 is 30, so in total we got that in the numerator what is left is only 30 times root 7, and in the denominator we have 3 times root 7 times 3 times root 7. It is actually 3 times 3 is 9. Root 7 times root 7 is 7, and 9 times 7 is 63 minus 21. So that is the equality that we have. So we know that 63 minus 21 is 42, so I will write it down. 7 plus x over 3 times root 7 equals to 30 times root 7 over, again, 63 minus 21 is 42. So in total we got this equality. Here we will multiply this equality by 3 times root 7, and we will get that seven plus x equals to 3 times root 7 times 30 times root 7 over 42. Okay. So 7 plus x equals to 3 times 30 is 90, and root 7 times root 7 is 7, and 90 times 7 is 630 over 42. $630 over 42 is 15. Here we will subtract from this equality 7, and we will get that x equals to 15 minus 7 is 8. So we found out that the value of x is 8 units. X, here you see that equals to x equals to 8 units. Okay, so we finished with method 1, with the first method. In the next step, I will present to you the second method. We will find out the value of x in the second method, and we will do here a construction. We will extend side BD by 3 units. Okay. And we will define this point as point M. We extended side BD by 3 units, therefore MB will be equal to 3 units. That is to say, MB equals to BD equals to 3 units. In the next step, we will join together points A and M by a straight line. We know that angle ABD equals to 90 degrees. It is given us the question. It is given us the question that angle ABD equals to 90 degrees. But what is the size of angle ABM? According to the rule that the sum of the angles on a straight line equals to 180 degrees, we know that MD is a straight line because BD is the side of the triangle and we extended BD by 3 units, so MD will remain a straight line because BD is a straight line. So MD is a straight line. MD is a straight line, and we have the rule that states that the sum of the angles on a straight line equals to 180 degrees. The sum of the angles on a straight line equals to 180 degrees. Okay. The sum of the angles on a straight line equals to 180 degrees. That is the rule. And we know that MD is a straight line, therefore the sum of the angles at any point on the straight line MD must be equal to 180 degrees, and especially at point B on the straight line MD, the sum of the angles must be equal to 180 degrees. So, which angles we have at point B on the straight line MD? At point B we have angle ABD that equals to 90 degrees according to what is given us the question. And we also have angle ABM. So 90 degrees plus the size of angle ABM must be equal to 180 degrees according to this rule that the sum of the angles on a straight line equals to 180 degrees. Therefore, the sum of the angles on the straight line MD at point B must be equal to 180 degrees. That is to say, 90 degrees plus the size of angle MBA must be equal to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that the size of angle ABM equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that the size of angle ABM is 90 degrees, that is to say it is a right angle. Therefore, triangle ABM is a right triangle. So we have here two right triangles, the right triangle ABD and the right triangle ABM. And in the next step we will focus on those two right triangles, and we will prove that those two right triangles can go into each other. Okay, so we will focus on triangles ABD, the right triangle, triangle ABD, and the right triangle, triangle ABM. So on those two right triangles, ABD and ABM, we know that MB equals to BD equals to 3 units, MB equals to 3 units according to our construction. We extended BD by 3 units, therefore MB equals to 3 units. It equals to BD, that is also equals to 3 units, because it is given us the question that BD equals to 3 units. So we have here MB equals to BD equals to 3 units, and we also know that those two angles are equal to each other because both of them are equal to 90 degrees. They are both right angles. So angle ABD equals to angle ABM, and both those two angles are equal to 90 degrees. Okay, we know that angle ABD equals to angle ABM equals to 90 degrees, and AB, side AB is a common side. We can write down that AB equals to AB. AB belongs to both triangles, to triangle ABD and to triangle ABM. So AB equals to AB, it is a common side. AB equals to AB, it is a common side, it belongs to both triangles. So we actually proved that right triangle ABD can go into the right triangle, triangle ABM, according to side angle side rule. So I write it down, triangle ABD congruent. This is the sign of congruent to triangle ABM according to side angle side rule. Okay, those two triangles, triangle ABD can go into triangle ABM according to side angle side rule. So what is side angle side rule? Side angle side rule is actually if you prove that two sides and the angle between them in one triangle are equal to two sides and the angle between them on the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. And we actually proved that in the right triangle ABD we have two sides, side AB and side BD, and the angle between them, that is a right angle, that are equal to two sides and the angle between them in the right triangle ABM. The two sides are AB and MB, and the angle between them is also a right angle. Therefore we proved that those two triangles can go into each other according to side angle side rule. So from the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. Those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So I'll write it down. So you can conclude from the fact that those two triangles can go into each other that those two angles are equal to each other. So that is to say angle ABD is equal to angle ABM angle ABD equals to angle ABM according to the rule that corresponding angles in congruent triangles are equal to each other. I'll repeat again. Angle ABD equals to angle ABM according to the rule that corresponding angles in congruent triangles are equal to each other. And we know that angle ABD equals to alpha. So from this equality we can derive that angle ABM also equals to alpha. So we can write here that angle MAB, angle MAB equals to alpha. Okay, what is actually here? Angle BAD, it is actually angle BAD equals to angle BAM. Okay, so angle BAD equals to angle BAM equals to alpha. Okay, those two angles are equal to each other, and it is actually angle BAD equals to angle BAM equals to alpha. And we also, from the fact that those two triangles can go into each other, we can conclude that side AM equals to side AD. AM equals to AD, according to the rule that corresponding sides in congruent triangles are equal to each other. So I'll write it down. Side AM of triangle ABM is equal to side AD of triangle ABD AM equals to AD according to the rule that corresponding sides in congruent triangles are equal to each other. Again, side AM of triangle ABM is equal to side AD of triangle ABD according to the rule that corresponding sides in congruent triangles are equal to each other. Actually, those two triangles congruent to each other, therefore the corresponding sides, that is AM and AD, will be also equal to each other. And if we define side AM as y, that is to say AM equals to y, okay, if AM equals to y, from this equality we can derive that AD also equals to y. Okay, AD will be also equal to y. Okay, so in the next step we will focus on triangle ADC. So on triangle ADC, we know that AE is angle bisector. AE is angle bisector. AE is angle bisector in triangle ADC. On triangle ADC, AE is angle bisector. So why AE is angle bisector on triangle ADC? Because of the fact that AE bisects angle DAC. That is to say, AE divides angle DAC to two equal parts, to alpha and alpha. Therefore, AE is angle bisector in triangle ADC. And according to the rule of the angle bisector theorem that I presented to you in the beginning of the lecture, the angle bisector AE divides side DC in a ratio of DE over EC. Again, angle bisector AE in triangle ADC divides side DC in a ratio of DE over EC, and that ratio equals to the ratio of the angle legs. The angle is actually this angle, and the legs of this angle is AD and AC. So the ratio between the legs is AD over AC. So the ratio between the legs, that is AD over AC, is the ratio that angle bisector AE divides side DC. That is actually DE over AC. That is according to angle bisector theorem. Okay? And what is the value of DE? The value of DE is actually 4 units. What is the value of EC? EC equals to X. X is the value that we are looking for. What is the value of AD? The value of AD equals to Y. So in total we got this equality that 4 over X equals to Y over AC. Here we will multiply equation number 1 by X. And we will get that 4 equals to, or it is better to multiply, okay, it is okay, Y times X over AC. So we will multiply equation number 1 by AC. And we will get that 4 times AC equals to Y times X. Okay. Here we will divide equation number 1, equation 1 by 4 in order to get the value of AC. And we will get that AC equals to Y times X over 4. Okay, we got the equation number 1 that states that AC equals to Y times X over 4. So in the next step we will focus on the big triangle, triangle AMC. So on the big triangle, triangle AMC, we know that AD is angle bisector. Again, in the big triangle, triangle AMC, we know that AD is angle bisector. So YAD is angle bisector on the big triangle, triangle AMC. Because of the fact that angle bisector AD bisects angle MAC. It bisects angle MAC. That is to say, angle bisector AD divides angle MAC to 2 equal parts. The first part is alpha plus alpha, that is to say 2 alpha. And the second part is also alpha plus alpha, that is to say 2 alpha. So actually, because of the fact that angle bisector AD in triangle MAC divides angle MAC to 2 equal parts, therefore AD is angle bisector in triangle MAC. And according to angle bisector theorem, the angle bisector AD divides MC in a ratio of MD over DC. MD over DC is the ratio, MD over DC is the ratio that angle bisector AD divides side MC of triangle AMC, and that ratio equals to the ratio between the angle legs, and the legs of angle MAC are AM and AC. So the ratio between the legs is AM over AC. Again, the ratio that angle bisector AD divides MC is MD over DC, and that ratio equals to the ratio between the angle legs, that is actually AM over AC. Okay, that is according to angle bisector theorem. I will repeat again. Angle bisector AD divides side MC of triangle MAC in a ratio of MD over DC, and that ratio equals to the ratio between the angle legs, and the ratio between the angle legs are AM over AC. So those two ratios are equal to each other according to angle bisector theorem. So what is the value of MD? The value of MD is actually 3 plus 3, that is to say 6. What is the value of DC? DC equals to 4 plus X. It equals to AM. What is the value of AM? AM equals to Y according to our definition over AC. So in total, this is actually equation number 2. We found that 6 over 4 plus X equals to Y over AC. Here we will multiply this equality by AC, and we will get that 6 equals to Y times 4 plus X over 6 times. So here, okay, here I multiplied this equality by 4 plus X, so we got this quantity. I actually multiplied the equation number 2 by 4 plus X, so, and we got this equality that 6 equals to Y times 4 plus X over AC. We will multiply this equality by AC, and we will get that 6 times AC equals to Y plus 4 over X. So here we will divide this equation number 2 by 6 in order to get the value of AC, and we will get that the value of AC according to equation number 2 is equals to Y times 4 plus X over 6. And we have already found out, according to equation number 1, that AC equals to Y plus X over 4. Okay, so we got the value of AC in equation number 1 and equation number 2, and I will create equation number 3, that states that AC equals to AC equation number 3 states that AC equals to AC, and we will place the value of AC according to equation number 1 in this side of the equality, and then we will place the value of AC that we found out in equation number 2 for AC. So, and we will get that AC according to equation 1 is y times x over 4 equals to AC according to equation number 2, that is actually y times x plus 4 over 6 . Okay, that is the equality that we got. Here we will divide equation number 3 by y, and it is allowable to divide equation number 3 by y because of the fact that y can never be 0. Why? Because y is the size of the side AM of the triangle, therefore it must be a positive number. It can never be 0. That is the reason that it is allowable to divide the equation number 3 by y. And we will get that x over 4 equals to x over 4. So that is what is left from equation number 3 after we divide it by y. Here we will multiply equation number 3 by 4 and 6, and we will get that so here we will open the brackets, and we will get that 6x equals to 4x plus 16. We will subtract 4x from equation number 3, and we will get that 2x equals to 16. We will divide equation number 3 by 2, and we will get that x equals to 8 units. So we found out that x equals to 8 units. The value of x is 8 units. That is to say, EC that equals to x equals to 8 units. So we finished with the second method. So in the next step I will summarize the lecture. Actually, we wanted to find out the value of x. We know that BD equals to 3 units, DE equals to 4 units, angle BAD is alpha, angle DAE is also alpha, and angle EAC equals to alpha. And we also know that triangle ABC is a right triangle, that is to say angle ABC is a right angle, it equals to 90 degrees. and we know that BD equals to 3 units, DE equals to 4 units, and we want to find out the value of EC that equals to X. Okay? So in order to find out the value of X, I presented to you the Engel-Bissector theorem. The Engel-Bissector theorem states that an Engel-Bissector in a triangle divides the side it eats in a ratio that equals to the ratio of the angle legs. First of all, AD is angle bisector in triangle ABC because of the fact that AD, angle bisector AD, divides angle BAC to two equal parts, to alpha and alpha. Okay? Okay? And angle bisector AD divides angle BAC to two equal parts, to theta and theta. That is to say, angle bisector BAD bisects angle BAC. And according to angle bisector theorem, the angle bisector AD divides side BC in a ratio of BD over DC. BD over DC, and that ratio equals to the ratio between the angle legs, that is to say, the angle legs are AB and AC, and the ratio between the angle legs is AB over AC. So the angle bisector AD divides BC in a ratio of BD over DC, and that ratio equals to the ratio between the angle legs, and relate to angle BAC. The legs of angle BAC are AB and AC, and the ratio between the angle legs are AB and AC. So the ratio that angle bisector AD divides BC is BD over DC, and that ratio equals to AB over AC. Okay? Let me read the angle bisector theorem again. Angle bisector in a triangle divides the side it eats in a ratio that equals to the ratio of the angle legs. Okay? So we will focus on the right triangle, triangle ABE. On the right triangle, triangle ABE, AD is angle bisector. Why AD is angle bisector in the right triangle, triangle ABE? Because it bisects angle BAE. It bisects this angle, that is to say, it divides it to two equal parts, to alpha and alpha. Therefore, AD is angle bisector in triangle BAE. Okay? So, according to angle bisector theorem, the angle bisector AD divides BE in a ratio of BD over DE. Okay, the angle bisector AD divides BE in a ratio of BD over DE, and that, okay, angle bisector AD in the right triangle ABE divides BE in a ratio of BD over DE, and that ratio equals to the ratio between the angle legs, that is to say to AB over AE. Okay, the ratio that angle bisector AD divides BE is BD over DE, and that ratio equals to the ratio between the angle legs, that is to say to AB over AE. But we know that BD equals to 3 units and DE equals to 4 units. So BD equals to 3 units and DE equals to 4 units. So we got that AB over AE equals to 3 over 4, and then we defined AB as 3K. AB equals to 3K according to our definition. So we placed the value of AB, that is 3K, in this equality, and we found out that the value of AE is 4K, so AE equals to 4K if AB equals to 3K. And then we continue to focus on the right triangle ABE. We know that in the right triangle ABE, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square plus BE square equals to AE square. AB square plus BE square equals to AE square. And AB equals to 3K according to our definition. BE equals to 3 plus 4, that is to say 7. BE equals to 7 units, and we have already found out that AE equals to 4K. So we got this equality, and we found from this equality that K equals to root 7 units. K equals to root 7 units. And after we found the value of K, we know that AB equals to 3K. So we can place the value of K inside AB, inside this equality, and we found that AB equals to 3 times root 7, and we know that AE equals to 4K. So we placed the value of K inside this equality, and we found that A equals to 4 times root 7, so we found out the values of AB and AE. Okay? Then we focused on the right triangle ABC. We know that in the right triangle ABC, tangent 3 alpha equals to BC over AB. Tangent 3 alpha equals to BC over AB. But what is the value of BC? BC equals to 3 plus 4 plus x, that is to say BC equals to 7 plus x. And we have already found out that AB equals to 3 times root 7, so in total we got that the value of tangent 3 alpha equals to 7 plus x over 3 times root 7. Then we focused on the right triangle ABE. On the right triangle ABE, we know that tangent 2 alpha equals to BE over AB. Tangent 2 alpha equals to BE over AB. What is the value of BE? BE equals to 3 plus 4. And AB, we have already found out that AB equals to 3 times root 7. So in total we got that the value of tangent 3 alpha equals to 3 over 3 times root 7. Okay? And then we focused on the right triangle ABD. On the right triangle ABD, we know that tangent alpha equals to BD over AB. Okay, on the right triangle ABD, we know that tangent alpha equals to BD over AB. But what is the value of BD? BD equals to 3 units, and AB equals to 3 times root 7. So in total we got that the tangent alpha equals to 3 over 3 times root 7. So we got the values of tangent alpha, tangent 2 alpha, and tangent 3 alpha. Okay? But we also know that tangent 3 alpha equals to tangent 2 alpha plus alpha. And in order to find out the value of tangent 2 alpha plus alpha, we use this trigonometric identity that states that tangent A plus B equals to tangent A plus tangent B over 1 minus tangent A times tangent B. And replaced the value that we found from tangents. Actually, we use this trigonometric identity in order to find the value of tangent 2 alpha plus alpha, and the value of tangent 2 alpha plus alpha is tangent 2 alpha plus tangent alpha over 1 minus tangent 2 alpha minus tangent alpha. And then we substituted the value of tangent 3 alpha by the value that we found out for tangent 3 alpha. We substituted the value of tangent 2 alpha and alpha by the values that we have already found out for tangent 2 alpha and alpha. And we got this equality. We have here only one variable that is missing, that is x, and we found out that the value of x is actually 8 units. So the answer to the question is that x equals to 8 units. This was the method number 1, and we solve the equality according to method 2. In method 2, we extended BD by 3 units. We defined this point as point M, and then we connected together points M and A by a straight line. And we know that MD is a straight line because BD is the side of the triangle. When we extended BD by 3 units, so it remains straight line. MD is a straight line, and we have the rule that states that the sum of the angles on a straight line equals to 180 degrees. So in the straight line MD at point B, the sum of the angles must be equal to 180 degrees. So here, what angles we have at point B? We have 90 degrees plus the size of this angle must be equal to 180 degrees. Okay, so 90 degrees plus the size of angle ABM must be equal to 180 degrees. Okay, so here we subtracted 90 degrees from this equality, and we got that angle ABM equals to the size of angle ABM is 180 degrees minus 90 degrees. It equals to 90 degrees. Okay, so angle ABM is a right angle, and then we proved that those two triangles can go into each other because MB equals to BD equals to 3 units. Those two angles are right angles, and AB equals to AB. Therefore, those two triangles can go into each other. From the fact that they can go into each other, we can derive that those two angles are also equals to each other. And if angle BAD equals to alpha, angle MAB will be also equals to alpha. And we also derive from the fact that those two triangles can go into each other that AM equals to AD. According to the rule that corresponding sides in congruent triangles are equal to each other. So if AM is Y, AD is also Y. Then we focus on the right triangle triangle, we focused on triangle ADC. We know that on triangle ADC, AE is angle bisector, and therefore, according to the angle bisector rule, we know that the ratio that angle bisector AE divides DC is DE over DC, and DE over DC, and that ratio equals to the ratio between the angle legs, that is AD over AC. Okay? And we know that DE equals to 4, EC equals to X, AD is Y. So we got this equation number 1. And then we also know that in the big triangle, triangle AMC, in the big triangle, triangle AMC, AD is angle bisector. Therefore, angle bisector AD divides MC in a ratio of MD over DC. MD over DC is the ratio that angle bisector AD divides MC, and that ratio equals to the ratio between the angle legs, that is actually AM over AC. From this equation, we know that MD equals to 6, DC equals to 4 plus X, and AM equals to Y. So in total, we got this equation number 2, and we have equation number 1. So we have AC in both equation number 2 and 1. And then we created equation number 3, that AC equals to AC. We substituted AC by the value that we found in equation number 1, and we substituted AC in this side of the equality by the value that we found for AC in equation number 2. We got this equality, and we solved this equality, and we found out that the value of X is 8 units. So X equals to 8 units according to the method, to the second method. Okay, thank you very much.